Okay, so far, you know what degrees are, right? You've measured everything you've ever done with angles in degrees, correct? So, yep, and we're putting everything in the coordinate grid now. So what do we start at? 0 degrees, right? And if we just do circles, one full revolution is 360 degrees, right? And then if we do another revolution, we have 720, and then so on and so on. All right. So degrees are a very circular measurement. In music, we use time, right, to control the flow of the music. Is time a circular measurement? Yeah. Thank God it's not, because this moment right here would repeat, and it would come back around and repeat. Okay, it would be kind of weird, right? None of us would ever exist, actually. So yeah, time is not something that comes back to the same moment and the same value every time, correct? So we need a different way other than degrees to measure time, okay? And time is a distance measurement. It's a length, okay? We consider it a length measurement in mathematics. Okay, we're just not measuring something physically, right? So here's how radians were developed in order to represent some real number mathematics, okay? If this is the unit circle, do you remember what the radius of the unit circle is? Okay, somebody said r equals 1, correct? Okay, what is the circumference of that circle? Right. Ring a bell, 2 pi radius is circumference. So 2 pi times 1, which is 2 pi, right? The measurement around that circle is 2 pi. Good? Okay. It just so happens that there are 2 pi radians is 1 revolution of the circle. Okay. In decimal format, what's 2 pi?
3.4. 6.28.
6.28. Okay, so if we're representing music, okay, mathematically we like perfect answers, right? 2 pi is a perfect answer. But in music, we like decimals, because time is usually measured in decimals. You'll say, I went for 2 pi seconds. Right? So if you're translating to music, this is more music oriented, right? Fractions and decimals are much more real world oriented than pies. Okay, so just keep that in mind. What this allows us to do is to do time across an axis. Okay, so we can do 2 revolutions would be how many radians? 4 pies, right? And then another revolution would be 6 pies. Okay, what that allows us to do, because this is a real number as opposed to a circular measurement, is to take our graph and instead of measuring in circular time, we can measure across time. And now we have a music-oriented time measurement. Okay, so we would have like 2 pi and 4 pi and 6 pi. Now we're in the real numbers, and we're good to go. Okay. What you need to be concerned about, there's a lot of fluff there, is radians versus degrees. And can you translate radians into degrees and use the trig functions with it? Okay, so most of it is going to be contained in one revolution. So if we have 2 pi as a full revolution, what's half?
1 pi.
Yeah, pi. Okay, that's pi radians. What would this be?
Half of pi.
Half of pi. 1 1/2 of pi. Right? And then everything in between. Right. Okay. That is illustrated. See, 0 pi's, 0 degrees. Pi over 2 is 90 degrees, right? But then we come in the middle, 45 degrees is going to be pi over 4, 30 is pi over 6, 60 is pi over 3. Okay, so we have a radian measure that relates to every degree measure. Okay. So you can now say, not only what is the cosine at 45 degrees, I can ask you what's the cosine at pi over 4.
Oh, what? Oh, right.
That's 45 and pi over 4 are the same thing, right? As far as the numeric value goes. Cosine at 45 is the same as cosine at pi over 4. Okay. So, and you already have this information in your hands. I told you not to worry about it until now. And now we need to start worrying about it. Okay. And again, if you get your music, okay, and it's a sound wave, and you have 0.04 seconds, that would be a radian value. And 0.04 is a radian measurement. Not perfect unit circle, right? But it is a radian measure because that's time. Okay. So don't use degrees with your music stuff, right? We're using radians. So when you're using your calculators, you need to be able to differentiate between when to use radians and when to use degrees. Okay? It should be pretty obvious. All right, so let's talk about how to translate between the two. So 360 degrees is 2 pi radians, right? That gives us our basis for a formulae to translate between the two. Okay, we have 2 of them, degrees to radians and radians to degrees.
Okay.
So I'm going to start there. So 180, right? 260 divided by 2 is 180. Divided by pi.
Do you want us to do that?
No. So if you take some number of radians and multiply it by that value, you get an output of degrees.
So if you say it's like 3 radians, you can multiply by that, and it'll give us degrees more.
Yeah. Make sure that's right.
Absolutely.
Yeah, that's right. That's what I was thinking. So, radians usually have a pi on them, correct? Okay, so if you look at the unit circle, radians have a pi on them. most of the time. You will see some that don't when you're working with time in music. Find an example. Okay. You want to get rid of that pi. So if let's say I have a 3 pi over 2 radians, and I want to get 2 degrees. This is going to get rid of that pi, correct? If that's how I know, this is how I remember which to use. So if I want to get rid of the pi, 180 divided by pi. So the pi's cancel. The 180 divided by 2 is 90. 90 times 3 is 270 degrees. Okay. So that's radians to degrees.
Where'd you get the 2 from?
Radian, this was a radian measure.
Oh, okay.
I wanted to convert it to degrees. Okay, so let's convert radians to degrees. Better? Okay, how do I convert degrees to radians? It's just the opposite here. So we take 360 and divide it across here, and we get pi over 180 times any degree is radians. Okay. And again, radians has a pi, so this will multiply it by a pi and give you the radian measure. Okay, so give me a degree measurement. Christian. No. 90, okay. So if we have 90 degrees, how many radians is that? 90 divided by 180 is a half, right? There we go. Okay. Questions?
That's straightforward stuff.
What? Radians are the real number measurement of time. Does that answer your question? So you do not have any more conversions. This is a mathematical representation of time. It's just a perfect number instead of a big decimal. All right. So we in the warm-up, cosine of 60 degrees was not the warm-up. Well, no, it's still there. Half, right?
Yeah.
Okay, that's the same as the cosine of pi over 3. Okay. Because those measurements give you the same output. Okay. We can't say they're equivalent because they're a little bit different. I'm kind of showing you that way, but they have the same value when they output. Okay. What about the, let's say, tangent of pi over 4? At this point, do you need to convert it to degrees?
45.
Yeah, you can. Okay, so if you need to, at this point, you can do this. I would encourage you to try and start steering clear of this, because pretty much everything calculus is right there, is radians. Okay? Yeah. You'll get used to it. We're going to use it enough to use it. So these give you the same value. This is the sine over cosine. Root 2 over 2, right? Which is 1. Okay. So, but like I said, if you need to make this 45, convert it. and do the math with 45, that's okay. It becomes less and less efficient. If you want to be efficient, you're going to want to be working in radians eventually. Okay, let us pray. Welcome back. All right. Questions?
No.
Most our music functions will be based in sine, okay? Because sine and cosine, you've seen on the unit circle that they are very related, right? Their values are sometimes the same, and sometimes they're just opposite, right? All cosine is a shift of sine, 90 degrees. So if I go cosine at 0 is 1, the cosine at 90 is the shift of 90 degrees because the cosine at 0 is 90, right? Okay. So all of this, the work we do with music and sound waves is based on the sine function, just for ease. Right? So if I say, what is the sine at pi? Zero, yeah, so we got it. 180 degrees. Right, again, if you need to translate, you can. Does music stop? Does time stop? Stupid question. At 2 pi radians, 1 revolution.
No.
Right, so, how would I interpret the sine at 3 pi?
1.5 revolutions.
Yeah, it's 1.5 revolutions, which is it's the same value as the sine at pi.
I'm not understanding what you're saying
So,
is
okay.
revolution in reference to the.
Here's a unit circle, right? Okay, so the sine at pi is a 1/2 of a revolution, right? Pi over 2. Pi. With a little flip out of it.
Yeah.
Okay, so what is sine at 1 pi, 2 pi, 3 pi's? Because time goes beyond 2 pi, or 6.28 seconds. Time continues, right?
Oh, okay, yeah, gotcha.
Okay, so yeah, we determined 1 revolution is 6.28 seconds.
That's what I was.
So we gotta keep going,
Yeah.
right? So you might have values that have more than 1 revolution. Just be able to relate those to the original value. So again, we're based in 0 to 2 pi, but we can go beyond that. We just have to make sure that we know what those are. Okay, so sine at 3 pi would also be 0, because that's 0, right?
Yeah.
Just, I guess, try not to make it harder than it needs to be. So the main point of today is, can you translate radians to degrees? And can you use a unit circle to find the value of functions of radians? Okay. And again, you translate radians to degrees. Okay, then say, what's the cosine at 5 pi over 6? Well, that's the cosine at 150, which is 3.02. Okay?
Yep.
That's there is a little bit more in this section if you are interested. The SAT usually includes a problem or two of what is left in 6.1 that we have not talked about. Sector measurement, sector area. Okay, so that would be can we find the area of a slice of a circle, or a pie slice of a circle? Yeah. The area of this is the angle measurement over 360 or 2 pi if it's in radians, and then the area of the circle, right? It's just a fractional, that's an A, fractional area of a circle.
Is the, which line is the angle measurement?
Or angle measurement would be, you know, just however far that is. Okay, so this is a definite item that you want to have in your melons. A, yeah, poorly written A. The other thing that they ask, very common, is what is the, okay, so this is sector. That is arc length. Arc length is a fraction of what measurement? Circumference. Yeah, so you have arc length is whatever angle measure over 360 times 2 pi r now. Because it's the circumference fraction, right? So that's something we don't do a lot of practice with, but it is there. And it is common on this. Okay, any questions about today? Radians?
You want us to do it on the board?
Those are yours. I told you the first, just put them in your notes. Okay. Tuesday, we'll move a little bit more into figuring out the frequencies of your notes. And then I'll show you what to do with that inside of the trig function. You can start writing those up. Okay. Basically, you type in denote frequency, and it gives it to you, and you put it in a formula.